What's up guys, welcome back to the channel. Today on this video we'll be proving this trigonometric identity. Well, we have to prove that the right hand side is the same as the left hand side. Now when you do this type of a problem guys, you have to choose the most complicated side, but it seems like here both sides are very complicated. So the challenge here is which one to choose. But to be honest with you guys, when both sides are complex, just simplify both sides. Now we're gonna start by selecting the left hand side and simplify it, and then we're gonna follow with the right hand side. They should both give us the same answer after simplifying both of them. Alright, before we start though, I would just like to say to you guys, at the end of this video there is a playlist whereby you can watch all the videos that are in that playlist in a sequence form. So the type of videos that we have in that playlist is solving for x, obviously the trigonometric equations, and also simplifying the trigonometric equations, and we also proving the trigonometric identities as well. So if you want to watch all of them, you can go to the playlist and click there and watch the in a sequence, by the way, in a sequence. So let's start before we waste any time. So we're gonna start with the right hand side. So I have to write here right hand side. Right hand side. Okay, let me just write the formula. 1 minus tan x divided by 1 plus tan x. Now we have to simplify this. Now if you've been watching my videos, you know that when I have a fraction like this, I prefer to write it this way. It's way much easier to write it this way. The reason why is because I don't want to have fraction divided by the fraction, so there will be a lot of lines there disturbing us. So that's what we're trying to avoid. Alright, so you rewrite this. Instead of writing this line here, we have a division sign, which is way much easier. Then if you didn't watch the previous videos, there are previous videos whereby we're supposed to prove and there was tan. I always say to you guys, when you see tan, change it to cos and sine, or sine and cos. Remember that. So we're gonna use the quotient identity for tan. It's gonna be sine x over cos x. There we go. And then we do the very same thing on the other bracket as well, whereby we're gonna change into sine x over cos x. There we go. Let me just create more space, because this problem is a bit longer as compared to other problems. Okay, and it might take time, so you have to be patient. Now on this triangle we need to find our denominator. As you can see, we have 1 and cos, so cos is the 1. So we start 1 into cos is gonna be 1, it's gonna be cos multiplied by that 1, it's gonna be cos x minus, because we have a minus here. Cos into cos is gonna be 1 multiplied by sine, we're gonna have sine x, and then this is gonna be like that. Okay, let me just fix our x. There we go. Alright, so we do the very same thing on the other bracket. We look at the denominator, we have cos x. Alright, we know that this is divided by 1. By the way, 1 into cos, it's cos multiplied by 1, so this is gonna be cos x plus, because this time around we have plus here, and then it's a cos into cos, it's 1 multiplied by sine. So this is gonna be sine x. So this is gonna be our second bracket. So now that we have this, we can change the sign there, the division sign into multiplication. But remember, when we do that, you need to understand that this bracket here, the denominator becomes a numerator and the numerator becomes a denominator. So let's do it. So we're gonna have cos x over cos x plus sine x. Right, so since we have multiplication, this cos and that cos, they're gonna give you 1. Multiply everything, you're gonna be left with cos x minus sine x, divide by cos x plus sine x. So this is gonna be our simplified version of the left hand side. We cannot go further than this. This is where we stop. This is well simplified. Now let's go back and look at the right hand side now. The right hand side. Now I'm gonna do the right hand side on the right of this problem. I mean the did I say? Oh gosh, this is the left hand side. This is the left hand side. I don't know what happened, guys. Here, this is the left hand side. Let's fix it. Okay, this is the left hand side, guys. I made a mistake. As you can see, this is the left hand side. Now let's look at the right hand side. The right hand side. Alright, so let's rewrite the right hand side. We have cos 2x over 1 plus sine 2x. Alright, so let's start solving this side. Now when you look at your numerator on the right hand side, this is a double identity. Guys, if you haven't done double identities, it might confuse you when I change this, but you can go to the icon there. That's where I actually derive some of the identities that I'm gonna change here. So go and watch those videos if you don't understand what's happening here, and you can come back and finish off this video. Alright, so I will change into cos squared x minus sine squared x, and then we divide and then 1. So this one as well, it's also the identity. The sine 2x is also identity, so it's gonna be cos. By the way, it's a double identity. The very same video that I posted on the icon, go and watch it. So it's gonna be 2 cos. Let's make it 2 cos and then multiply by sine x. So this is a double identity for sine. Okay, now let's create more space. Now when you look at this problem here, guys, when you look at this problem here, let's continue. When you look at this problem here, the numerator there, this is a difference of 2 squares. So let's do it. Difference of 2 squares, we know that we're gonna have cos x plus sine x, right? Just fix my x, multiply by cos x minus sine x. Alright, so this is our factorization for a numerator. But when you look at the denominator, let's look at this. We can change this one using the square identity. If you still remember, let me just write it very quickly here. We know that sine, let me just say cos squared x plus sine squared x, all these are equaling to 1. There is this double identity. I think you guys know about it. Alright, so let's change this into that. So we can say cos squared x plus sine squared x. Remember, this is this one here, then plus, then we add the 2 cos x multiplied by sine. There we go. So we continue. There's nothing that we can do at the moment on the numerator, so we rewrite it as it is. So let's rewrite it as it is. Okay, plus sine x, and then we gonna continue there, cos x minus sine x, and then we divide. To make things easier, we can say, how about we say cos squared x plus 2 cos x multiplied by sine x, plus, because we still have sine x squared, okay, sine squared x in fact. So this, as you can see, we can factorize this. Look, if we allow cos to be, for example, let's look at the denominator there. If we allow cos to be x, we can say it's x squared. You just create a barrier here so that we don't get confused. Alright, if we say cos is x, we can say this is x squared, and then we say y is sine, so we're gonna have 2x y, and then sine is gonna be y squared. You guys see the denominator there, it's the same as this one. If we say sine is x, cos is x and sine is 1, so we can factorize this thing like this, guys. Do you guys see? We can say x plus y, x plus y. When you factorize this is going to take you back. If you say x multiplied by x is going to be x squared, x multiplied by y is going to be 1xy, and then we have y multiplied by x is going to be another yxy. When you add them, they're going to give you this 2xy, and then you say y multiplied by y, and you have y squared. So we can factorize this one on the bottom. So, but we have to rewrite our numerator, because at the moment we are still dealing with the denominator, guys. At the moment we are still dealing with the denominator. So of course x minus sine x. I hope you guys understand though, because it feels like it's a lot of information, but there's no any other way that I can explain this other than showing you those examples there. So let's factorize. So remember, when you look at the example there, it's gonna be cos x plus sine x, and then we have another bracket which is going to be cos x plus sine x. Alright, so look at this cos x plus sine x is going to divide that cos x plus sine x, and then what is it that we're going to be left with? We're going to be left with cos x minus sine x on the numerator, divide by cos x plus sine x on the denominator. When you look at that answer there, it's exactly the same as our answer here. So this answer here is the same as this one here. Can you guys see? And this side is the left hand side, whereby this side is the right hand side. So guys, when you have a problem whereby both sides are complicated, it's best to simplify both sides, and you will have the very same answer, as you can see from this problem that we just worked out. Okay people, I hope you understood. I hope you you will rewatch wherever you don't understand. If it so happen that you can't understand still, do not forget to comment and ask. Probably I'm gonna able to help you there on the comment section. And if there is an easier way of solving this, you can also comment as well. But if this video did help you to understand or how to solve, or it was very useful, do not forget to like the video and also subscribe to the channel, because there's more videos to come concerning maths. So guys, don't forget to share these videos to your friends. And also, if you want to watch the playlist whereby I solve the problems like solving for x, trigonometric equations, proving like this one here, proving the trigonometric identities, and also last, the simplification of trigonometric equation, there is a playlist that is going to appear at the end of this video. Click on that playlist and watch those videos in a sequence. Thank you very much guys for watching. Till next time, cheers.